This is Iulia Iordanescu, and this is my project on leveraging time series foundation models for survival analysis. My project is overseen and heavily supported and guided by Dr. Abby Turner and Dr. Artur Dubrowski. So, an enormous thank you to both of them for all of their help this summer. Let's begin. The whole point of survival analysis is to help answer the question of when an event occurs, not whether it occurs. This is a question of interest for most domains. You don't actually really care about if something happens. You want to know when exactly is it going to. And this is not something that's restricted to one domain. Although, for example, like our paper is restricted only to the medical sector. This can be applied for economics, and also all various kinds of places where this question pops up. So ICUs chart vital signs continuously. So this is a natural place where we can find time-varying covariates because this is the kind of survival analysis that could potentially be used by time series foundation models. And that has not been investigated yet. We have seen that time series foundation models transfer very well to time series tasks regarding forecasting, imputation, anomaly detection, but survival analysis is not something that we've seen them perform in yet. Especially, we have not seen whether or not their embeddings of a trajectory, of a covariate trajectory under a survival objective is useful or not. And that's really the point of this project, is working towards a benchmark where we pair different time series foundation models with different survival heads and comparing that against established methods for survival analysis. So this project is a stepping stone towards that. And even this benchmark that I just described is still kind of a pilot benchmark because it would be in a static prediction setting, but time varying covariates probably fit in best with dynamic survival. So that would be the most complete form of the benchmark. So this is kind of a stepping stone. This paper and project is kind of a stepping stone towards that pilot benchmark, not the full complete one. Okay. So a trajectory needs to become a representation, which is a vector. The question is, how do we choose this vector? And this is what we're studying here. We're trying to see if the embedding produced by a time series foundation model can act as a representation for this covariate trajectory. And that's exactly what we test here again as a stepping stone towards that benchmark by looking at moment, which is a time series foundation model, and comparing its embedding against the representation of a handcrafted feature representation, and pairing each of these with the same survival head, which is the Deep Survival Machines head, DSM. Both Moment and DSM were actually produced in Auton Lab here at CMU. So this is not only is this a natural marriage between a TSFM and survival head, but also specifically for Auton Lab. So we investigate just one covariate here as part of this stepping stone. And that one covariate is heart rate, which again, yes, is time varying. And it needs to be given to each moment and to the handcrafted features. Moment comes in 3 flavors or variants: small, base, and large, and we test all 3 here. And to compare performance across these 2 arms, the hand-engineered features arm and the moment arm, we look at the area under the receiver operating curve and the integrated Breyer score. Specifically for area under receiver operating curve, this can be applied in a time-dependent setting, and that's exactly what we do here for 7 days and 14 days out, and this will make more sense once we've discussed the data setup, which is right here. So the patients we're looking at come from MIMIC-4. This is a standard benchmark data set for clinical settings. And like I said, we are only looking at heart rate just for now. We fix a landmark at 48 hours, and we hourly bin the heart rate values into one of these 48 bins, and we select the median per bin. Nothing is imputed. Again, this is a very specific step and looks at a very specific group of people in the ICU, which is a major limitation. But once again, just to kind of get a first pass, this is what we do. And absolutely in future work, we would probably keep people who don't have a complete set of bins of 48. We'd probably use forward fill and backward fill because that is a standard practice. We just didn't want to dilute any signal and just, again, once again, have a first pass look at what exactly is happening here. So in the end, our cohort comes down to be just a little over 10,000 people, and about 21.4% of them experience the event of all-cause mortality 28 days after this landmark. So kind of as expected, we see that the hand engineered features really do probably a lot better than Moment, but this is also not exactly the fairest comparison because the dimensionality of Moment is so huge, even in the smallest variant, against the hand engineered features. And so you can see that the generalization between the hand engineered features and the generalization of Moment across all three of its variants from train to test is not great. But this is absolutely something that we'd have to address in a future step. Okay, so yeah, once again, this is just an out of the box results. This is one covariate, it's one seed, one foundation model, one survival head. It's a stepping stone towards a pilot benchmark, not even a pilot benchmark. And it's especially not a verdict on time series foundation models in general, or even Moment. So there's a lot of future work that needs to be done to really rigorously be able to make a claim about time series foundation models as a whole and their ability to use them in survival analysis. And this is just kind of one stepping stone towards that. We definitely need to pair more time series foundation models with other survival heads, and also fixing kind of one sort of standard survival configuration, landmarking and how many days of follow-up we look at. Like, these are absolutely things that we verified by literature, but they might not necessarily be able to be used as input for other competing methods which need to be investigated. And once again, this is a static prediction setting, and we would hope that the more complete benchmark also incorporates a dynamic prediction setting, which is most naturally paired with time varying covariates. Yeah, thank you very much. And thank you once again to Dr. Abby Turner and Dr. Artur Dubrowski for this support and for all of their help this summer. Thank you very much.